All right. Hey, everybody. You survived your first day of school. Congratulations. Um, Today, we're going to talk about binary numbers. And in order to really understand what I'm talking about in this video, I want to make sure that you've already watched the Flippy-Do tutorial video and have yours completely made and ready to go. But besides that, you can just kind of listen and really try to follow along and understand how binary works. This is going to be a really foundational idea that will come up again and again and again. So I want to talk about just regular numbers, okay? So in normal life, we live in a decimal system. Okay, and that is what we call base 10. Now, why is it base 10? Well, let's just consider a number. Let's say I have 572. Okay, what does 572 really mean? This means that I have two ones. This 7 doesn't mean that I have 7 ones. It means that I have 7 tens. And this 5 means that I have 5 100s. Okay. Now, let's say I have a 4-digit number, 3,572. Well, this is the ones place, right? So I have two ones. This is the tens. This is the hundreds. And this is the thousands, right? And we can obviously keep adding place values into our numbers, but you should be able to see the pattern here. These are all powers of 10, all powers of 10. So you might recognize right away that 10 is 10 squared. 1,000 is 10 cubed. 10 is 10 to the 1. And 1 is 10 to the 0 because this might be a little flashback for you. Anything to the power of 0 is 1. 10 to the power of 0 is 1. So this is what we call base 10. So this number tells me how many ones there are. This one tells me how many tens there are, how many hundreds there are, and how many 1,000s there are. And if we keep adding more digits and the number keeps getting bigger, the pattern would follow, right? If I put a 1 here, that tells me how many 10,000s there are, which is 10 to the 4th. And we could keep going, okay? So understanding this, we are now going to translate into binary. And binary is base 2. Binary is base 2. Okay, so base 10, we have 10 different symbols that we use to write our numbers. 0, 1, 2, 3, and all the way up to 9. That's 10 different numbers that we can use for our different digits. So in base 2, we're only going to use 2 different digits, and it's a 0 or a 1. Okay, and this is where our Flippy-Do comes in, and you can see that we already have our powers of 2 here, and then this right here tells us how many or what we're actually counting up, right? So if I made one with decimal, I would have a 1 here and a 10 here and a 100 here. But when we're in base 2, this first one tells me how many ones we have. The second place value tells me how many 2s, how many 4s, how many 8s, and so on. So Let's do a little example here. Let's just say, for example, I have the number 101. Okay. I'm going to look at my flippy-do. So make sure you have your flippy-do. Follow along with me here. And I'm going to flip up. So I have 101. Now, just like with regular numbers, if I have zeros in front of it, those don't really matter. We build our numbers from right to left. So 101. This tells me that I have 1 4, 0 2s, and 1 1. 1 4, 0 2s, and 1 1. So 101, if I were to convert that into decimal, that would be 5 because we have 4 plus 1. 4 plus 1 is 5. Okay, let's try another example. Let's say I have 1 1 1 1. Okay, so I'm going to use my flippy-do again. Let's see if I can zoom out a little bit here. That's better. Can see a little more. Okay. 1 1 1 1. I'm going to use my flippy-do. Flip it up so that the last 4 spots are showing 1. And what does this mean? This means that I have 1 8, 1 4, 1 2, and 1 1. So to figure out what this is in decimal, I'm going to do 8 plus 4 plus 2 plus 1. 8 plus 4 plus 2 plus 1 is 15. All right, so that is our brief introduction to binary numbers. You're going to watch the next video, and you are going to need your 1.4 activity guide.